Good morning, madam. My name is Harsha Kaur from BMI Cohort 10A, and today I'm going to be talking about comparison of radionuclide imaging with other modalities. Okay, so radionuclide imaging refers to the imaging of internal body parts by detecting radioactive emissions from an injected radionuclide that have been dispersed differentially throughout body tissues. Okay, so this is the general differences between nuclear medicine and other imaging modalities. Examples of modalities for radionuclide imaging is single photon emission computed tomography, SPECT, positron emission tomography, PET. And then other imaging modalities would be MRI, CT scan or X-ray, and ultrasound. Okay, so this is the comparison of radionuclide imaging with other imaging modalities. Okay, so there are many points to consider. But I'm only going to talk about the main points, which is the principle. So the principle for SPECT is gamma emission, for PET is positron annihilation, for MRI is magnetic resonance, for CT scan is absorption of X-ray, and ultrasound is high frequency sound waves. The next point would be the main characteristics of radionuclide imaging and other modalities. And then the next would be the component application, cost, and radiation source and type for radionuclide imaging and other modalities. So I'm only going to be talking about the component here. So the components for SPECT is collimator, scintillation crystal, photomultiplier tube, and computer. And for PET is gantry, subject table, detector or camera system, and computer system. And for MRI is main magnet, gradient coil, radio frequency coil, computer system. For CT scan is X-ray tube, gantry with a ring of sensitive X-ray detectors and computer. And for ultrasound, it's transducer, control panel, and monitor. Okay, so next, the image formation for radionuclide imaging and other modalities. So for SPECT here, as they spin around the patient, gamma chromas can provide spatial information on the radionuclide's distribution within tissues. The efficiency and spatial resolution on the detectors are improved by using multiple gamma cameras. Then which is usually in axial slices. The projection data obtained from the cameras is reconstructed into three-dimensional images. And as for PET, gamma rays are emitted due to the radiopharmaceuticals injected into the body, which is then detected by the gamma cameras to form three-dimensional images. And as for MRI, signals to the body is sent by the radio wave antenna, and then the radio frequency receiver detects the emitted signals. The returning signals are converted into images by a computer attached to the scanner. Basically, the computer converts the received data or signals through the use of a Fourier transform into an MR3D image. And as for CT scan, image formation involves three phases, which are the scanning phase, which produces data, the reconstruction phase, which processes the acquired data and forms a digital image, and the digital to analog conversion phase, which produces visible and displayed analog image, shades of gray. And then the next one is ultrasound. Image produced is based on the reflection of the sound waves of the body structures. The information necessary to produce an image is provided based on the strength, amplitude of the sound signal, and the time it takes for the wave to travel through the body. The image storage for radionuclide imaging and other modalities would be picture archiving and communication systems, SPECT, and digital imaging and communications in medicine, DCOM. The advantages and disadvantages for radionuclide imaging are, okay, for the advantages is non-invasive, identify active diseases after therapy completion, target tissue function and all similar target tissue can be examined, high sensitivity. And as for disadvantages of radionuclide imaging is low spatial resolution, long scan times, high costs associated with radio tracer production and administration, and radiation risk due to the administration of radionuclides. So you can see these are the images here. You can see the differences, the comparison between radionuclide imaging and other modalities. And that is all from me. Thank you.